All right, good day, everyone. Welcome to officially Unit 3. To start Unit 3, basically, as we talked about yesterday, or even in class today, is the focus is going to be trig, okay? And to really do trig, at least the start of it, we really have to start to understand some small things about trig, okay? Um, so the first couple of lessons that you're going to see is going to really revolve around how do we represent a trig function? What do we have to really look for when we're dealing with trig? Okay, what angles do we have to look at? How do we have to label certain things? How do we find certain degree measures? Okay, all these things are going to be important for us because they're going to help us describe a particular function. Okay, which eventually is going to be like our sine, our cosine, our tangent, or even our inverse functions of those values. Okay. So for the first couple lessons, a lot of it's just going to be going over certain terms because there's going to be a large amount that we have to know so we can actually solve out these examples. Okay. So with that being said, let's go ahead and try some of these out. Let's go ahead and look at what we're dealing with. Okay. So in the first case, understand that to really look at trig, first and foremost, we have to understand angle measures. Okay. We have to understand the difference between an acute, an obtuse, and especially something called a right angle. Okay. And I almost assume that a lot of you probably know this before. You probably have all taken some sort of geometry class. So if I want to look at an acute angle, probably a lot of you do understand the fact that it's going to be an angle that is going to be quite small. Okay. And it's going to be in between 0, but it has to be less than 90. Okay. An acute angle is going to be between 0 and 90 degrees. Okay. While an obtuse angle is going to be in the other route. Okay. That was just a bell. Sorry about that. The obtuse angle is going to be the other route, obviously, off of that. Okay. I want to basically be able to go all the way up to the value of a straight angle. So this is going to be between x has to be greater than 90 because it can't equal 90 because we have an angle specifically for that. Oops. And up to 180. And to be all honest with you, I probably shouldn't even write this either. Technically, if there's a 0 angle there, then it's not going to be an acute angle. Okay? So acute and obtuse angles are listed there. Next thing we have a right and a straight angle, which are probably going to be the more important types of angles that we see, right? A right angle is x is 90 degrees, and a straight angle is when x is 180 degrees. Okay? Each of those values are going to be important for us to really understand. Okay, so once again, not doubting that you probably know that. You probably have all that information down pat, but we want to be able to kind of refresh those and make sure we have a decent understanding of those values. Okay. Along with that, we also want to understand how an angle measure works on a typical angle plane. Okay. Because we want to understand how do we actually mark things out? How do things work when we're dealing with something like this? Okay. So when we're dealing with trigonometry, we have something called a fixed ray. Okay. Where this is kind of how a ray looks. This is a ray. Okay. Two lines connected to one another that form an angle. Okay. Well, within this value, what we want to be able to do is understand how can we use this to our advantage. Okay. Well, there's a couple things you have to understand. First off, there's always an initial side. Okay. This line here is always going to be our initial side, or we call it that because that's our starting point. No matter what, whenever we're dealing with an angle, at least especially with trigonometry, that's where we always start at. That's 0 degrees. Or if we go one full rotation, that's our 360-degree line. Okay? After that, we have our terminal side. This is what actually creates the angle. Okay? The terminal side is where we actually write that second portion that develops our angle. So for example, if we look at this value down here, the initial side is where we start, and this is our terminal side. Okay? Now, what we're going to be talking about in a sec here is how we actually develop angle measures. Okay? If I look at this angle measure, if I go from counterclockwise, this is considered to be a positive angle. Versus this one, when I go when I do go clockwise, that's actually backwards in trigonometry, and that's considered to be a negative angle. Okay? So, a couple things you kind of want to understand, a couple things you want to just take note of, and so you can truly understand these values. Okay? So, let's kind of discuss some more things about this. Okay? We talked about the terminal side, we talked about the initial side and how that's important. So let's try to really look into this and try to see, like, okay, how would this actually work? So draw an angle described in standard position and then give it the actual degree measures. So let's say we have 1/4 of a complete counterclockwise rotation. Okay. So we go draw our angle. Technically, we have our initial side right here. So that's where we start at. 1/4 would be a fourth of this graph. So we would have our value leading up to there. And if you think about this, this would be a 90-degree angle, a fourth of a 360-degree rotation. Okay. 1/2 of a complete counterclockwise rotation, same idea. We have our initial side. If I go a complete half, our terminal side's right there. And our angle at 1/2 would be 180 degrees. Okay. And if we continue going on with this, one complete counterclockwise rotation. Okay. Once again, the whole idea is that a full rotation is going to be 360 degrees. So what is that going to represent in the long run? So if I go one complete counterclockwise rotation, that's all the way around one time. That's a 360-degree angle. Okay. Honestly, this one's kind of funny too because our initial and our terminal are going to be at the same exact location because I went one full rotation around. But what happens when we start going clockwise? Okay, everything we've done so far has been counterclockwise, which have given us positive angles. Let's say we go counterclockwise. Okay, our initial side's here. Let's say I wanted to go 1/8 of a complete counterclockwise rotation. Okay, well, that would lead me to about right here. And I want to try to think of what is this possible angle that I'm given. Okay. Well, an easy way to do this is I can take 1/8 and set that, or excuse me, multiply that by 360 since it's 1/8 of the total. If I were to work that out, okay, I would get a value of -45 degrees. Okay. Now understand, it's a negative degree angle because I'm working backwards from the actual terminal angle or from the actual initial angle, okay? The terminal angle went backwards, so that's a -45-degree angle. But here's the other thing I want you to think about. In this case, if I worked this route, if I went this direction, this would be a 315-degree angle, okay? So notice the slight difference there. A counterclockwise motion is going to give you that positive rotation. The clockwise rotation is going to give me that negative negative degree measure, okay? But then the key thing you always want to understand is if you think about both of these combined together, that's still going to come out to be 360 degrees, okay? So whether way you're going, it's always going to make sense in the long run of that this is a 360-degree angle, okay? But let's continue on and go from there, all right? So the next one we want to talk about is basically we want to talk about something called a coterminal angle. Okay. And what a coterminal angle is, it's basically going to be a value that is going to be the same exact as the original. Okay. And what this means is not necessarily the actual number, but position. Okay. For example, if I had an angle at, let's say I had an angle at 90 degrees. Okay. So here's this value. We have our initial angle and we have an angle at 90 degrees, right? Well, if I wanted to find a coterminal angle, that would mean I could take this value and technically, if I went all the way around a full rotation, I would at some point be back at 90 degrees. Well, what the purple line did there is, in all honesty, I just took the 90, the original, and I added one full rotation, which was 360 degrees. Okay? So a coterminal angle of this would be 450. And technically, I can keep adding 360 degrees to that to continuously get more coterminal angles. The other side of it is I can also work backwards. Okay? If you think about it, this, and I know I'm taking away a lot of that. That's fine. This is technically a 90-degree angle if I worked from counterclockwise. What if I worked backwards and went from this line all the way to here, right? Isn't that also the same position? Okay, I didn't go one full rotation, but I did go backwards from my initial side. Well, this is also a coterminal angle. I could take that original and subtract 360 from it to get negative 270 degrees. Okay? So the idea is that 450, 90, and negative 270 degrees are all at the same position of this graph. So notice how it repeats itself, even though I have different angle measures, because it's that constant rotation around dealing with angles, I can always repeat myself using different values. Okay? The whole idea of the reason that we have coterminal angles is that if I take an angle and I continuously rotate, eventually every single time I reach back at that point. Okay? So this list here could constantly keep going as long as I add the 360 to it or as long as I subtract the 360 from it. Okay? That idea is something I want you to kind of keep in mind overall as we move forward. Okay? Currently, we're going to be dealing with this information like a graph. Okay, I know this is where we kind of left off remote learning last year with Algebra 2 honors for a lot of us, but once we get into like graphing, this is where this idea is going to become important. The idea that we always repeat at some certain position of the graph. Okay, but that's the idea of a coterminal angle. It's that I can add or subtract 360 degrees to get multiple angles at the same position. Okay, the last thing we're going to talk about is how to find an arc measure. Okay. Because in this case, what we want to be able to do is be able to figure out what's the actual length of this circle. Okay, and to do this, we're going to need two specific things. We're going to need to know what the radius is equal to, okay, as listed there, and we're going to need to know what our actual degree measure is, which is going to be n. And then in that process, we're going to use this equation provided to us to actually solve that out. So to quickly just talk about one, just so we can kind of work through it, okay? In this case, so they give us this particular equation. It's always going to be the area of, the circumference of a circle, which is 2 pi r, times the actual angle measure, which is n over 360. We can go ahead and plug these values in. This is just going to be 2 pi times 8 times 60 over 360. Okay. If I simplify this, this is just going to be 16 pi times 1 over 6, which, if I multiply those together, is going to be 16 over 6 times pi. Okay? And I could even simplify that even further. That fraction can be simplified into 13 over 3 times pi. Okay, so notice if I want to solve out these particular arc measures, I can easily take this value and simplify it using this process. Okay, once again, the whole idea is that if this is the original circumference of the problem, the 60-degree mark or the circumference of just this part of the circle is going to be 13 over 3 pi. Okay, which once again kind of cuts down a lot. Right? If you really want to understand the equation too, one of the things I want you to look at is kind of what is it representing? If this is the whole circumference of the circle, then what this is doing is it's saying, okay, now we're only taking a portion of that whole circle, okay? 360 degrees is the whole degree measure. We only want a certain value of it. So basically what we're doing in this equation is we're taking circumference times this portion of the circle, okay? But that's kind of the last thing we're going to be covering today. I know it's a lot of hodgepodge different material. 14.2 is kind of the same way, so we'll kind of talk about that, and that'll be an over break thing that we'll kind of come back and talk about. But once again, this is kind of what we want to lead you off on so you can see it and then be able to go through this information, okay? Make sure you answer any questions that are in the Ed puzzle. But besides that, I will see you in class tomorrow, and have a great day.